Did you know that high-performance liquid chromatography, or HPLC, has its roots in the oil industry? Yes, you heard it right. The technique that we widely use today in chemistry labs and pharmaceutical industries worldwide actually originated in the oil sector. But before we delve into it, let's simplify what chromatography is. Imagine you're at a race. You have sprinters, long-distance runners, and those in between. Now, when the race begins, the sprinters dash ahead, the long-distance runners lag, and the rest fall in between. Chromatography works in a similar way. It's a race at the molecular level where different compounds move at different speeds, allowing us to separate and identify them. High-performance liquid chromatography, the star of this analogy, is a sophisticated type of chromatography. In the early 20th century, Russian botanist Mikhail Tzvet used it to separate plant pigments, which he called chroma meaning color, and graphene meaning to write. Hence, the term chromatography. However, the modern HPLC we know today was born out of the oil industry's need in the mid-20th century. They needed a fast, efficient method to separate complex mixtures of hydrocarbons. This led to the development of column chromatography, which eventually evolved into HPLC. Today, HPLC is not just confined to the oil industry. From testing the quality of the air we breathe, to the food we eat, to developing new medicines, HPLC plays a pivotal role in our lives. It helps us understand the world around us at a molecular level and solve complex problems with precision and accuracy. So, it's safe to say that HPLC is a technique that's not just for chemists. It's a fascinating tool that brings the invisible world of molecules to light, contributing to numerous fields and impacting our lives in ways we might not even realize. Now, let's delve into the intriguing concept of the external standard in high-performance liquid chromatography, or HPLC. When we talk about an external standard, we are referring to a known substance, which is not present in the sample being analyzed. This known substance, the standard, is used as a point of comparison to identify and quantify the contents of a sample. In the world of high-performance liquid chromatography, the external standard method is a very common technique. When we use this method, we prepare a separate solution of a known concentration of the substance we are interested in. This solution is then run through the HPLC system before or after the sample. The resulting chromatogram is used as a reference or standard to calculate the concentration of that substance in the unknown sample. But why is the external standard method so important in chromatography? Well, it's all about precision and accuracy. By comparing the sample to a known quantity, we can make more accurate determinations about what's in the sample and in what amounts. This method is especially useful when dealing with complex mixtures or when the exact composition of the sample is unknown. Additionally, this method is relatively simple and straightforward. It doesn't require the standard to be present in every sample run, which can save time and resources. However, it's worth noting that this method assumes that the response factor, which is the relationship between the concentration and detector response, is constant for each run. If this assumption doesn't hold true, it could lead to errors in the analysis. In essence, the external standard method is a way to quantify the components in a sample. It provides a benchmark, a standard by which we can measure and understand the complex world of chemical compounds. And that, in turn, helps us to unlock the secrets held within everything from a cup of coffee to a sample of river water. The external standard method may sound complex, but it's actually quite straightforward once you break it down. To begin, let's talk about the preparation of the standard. That's your starting point. Imagine you're preparing a recipe. You need to know the exact ingredients and their quantities to get your desired dish, right? In the same way, preparing an external standard involves knowing the exact concentration of the analyte of interest. This is typically done by dissolving a known amount of the analyte in a known volume of solvent to create a solution with a known concentration. This is your external standard. Next, we move to the use of this standard in HPLC, short for high-performance liquid chromatography. This is where the magic happens. The prepared standard is injected into the HPLC system. Here's where it gets interesting. The analyte in the standard is separated from the other components in the mixture. It's like a race where each component runs at a different speed. The analyte will reach the finish line, or in this case, the detector, at a specific time based on its properties. This time is known as the retention time. Now, the detector measures the amount of analyte that passes through it based on the intensity of the signal it produces. The more analyte, the stronger the signal. This signal is then plotted against the retention time to produce a peak in a chromatogram. The area under this peak is directly proportional to the amount of analyte in the standard. But what does this peak tell us? This is where we interpret the results. By comparing the area of the peak for the analyte in the sample with the area of the peak for the analyte in the standard, we can determine the amount of analyte in the sample. It's like comparing two runners. If one runner crosses the finish line twice as fast as the other, then they are twice as fast, right? Similarly, if the area of the peak for the analyte in the sample is twice that of the standard, then the concentration of the analyte in the sample is twice that of the standard. There's one last thing to note. The external standard method assumes that the response of the detector is linear. That is, if you double the amount of analyte, the signal from the detector will also double. This is crucial for the method to work accurately. And that's how the external standard method works in HPLC. It's like a roadmap for your chromatography journey. So, what have we learned about the external standard in HPLC? Our journey today took us into the fascinating world of high-performance liquid chromatography, or HPLC, a powerful tool used in analytical chemistry. We learned that HPLC is a technique used to separate, identify, and quantify each component in a mixture. It's employed in a wide range of fields, from pharmaceuticals to food and beverage industries, environmental testing, and more. In the heart of HPLC, we discovered the external standard method, a critical component that ensures the accuracy and reliability of our results. This method is all about comparing the response of the sample to that of a standard solution. By preparing a known concentration of the standard solution and comparing it to our unknown sample, we can accurately determine the concentration of the components in the sample. But how does this method work in practice? We delved into the step-by-step explanation of the external standard method. First, we prepare a calibration curve using the standard solutions of known concentrations. Then, we measure the response of the unknown sample and compare it to this calibration curve. This comparison allows us to determine the concentration of the components in the sample. What's important to remember here is that the external standard method is not a standalone process. It's part of a bigger picture, the intricate world of HPLC, and it's crucial in ensuring accurate and reliable results. But like any scientific method, it also has its limitations. It assumes that the sample and the standard behave identically in the system, which might not always be the case. So it's essential to understand the limitations and work within them to get the best results. In the end, the external standard method is a vital tool in our HPLC toolkit. It's a guide, helping us navigate through the complex world of HPLC, ensuring that we obtain accurate and reliable results in our quest to understand and quantify the components in a mixture. Remember, the external standard method is your guide to navigating the complex world of HPLC. Now, you're one step closer to mastering the art of HPLC. With a deeper understanding of the external standard method, you're equipped to explore the vast landscape of high-performance liquid chromatography. Remember, the beauty of science lies in its endless pursuit of knowledge, and HPLC is no exception. As we've seen, HPLC plays a significant role in various industries, from pharmaceuticals to environmental testing. It's an intricate dance of science that's as fascinating as it is vital. But our journey into the world of HPLC doesn't end here. In our next video, we'll delve into the intriguing universe of internal standards in HPLC. Imagine a method that allows for even greater accuracy by compensating for variations during analysis. Sounds exciting, doesn't it? So, as we wrap up today's exploration, remember to keep that scientific spirit alive. Stay curious, keep learning, and don't forget to subscribe for more.